Hello, ladies and gentlemen, and welcome to another wonderful lesson with Mr. Wheezy. So, picking up where we left off, as we were talking about the trig functions sine and cosine. We're also going to use those and apply those into some things here today a little bit. But before we do that, let's do the kickoff from last time. So remember, sine is opposite over hypotenuse. So if we're here at A, 3 is opposite, 5 is your hypotenuse, 4 would then be adjacent. So for sine opposite over adjacent, 3 over 5. For at C, now everything shifts. 3 becomes the adjacent, 4 becomes the opposite, and therefore 5 is still the hypotenuse. But for sine, opposite would be 4 over 5 at C. For A, if we go to cosine now we're looking for that adjacent side, so the side that's touching the angle and the hypotenuse. So 4 over 5. And if we go over here to C, 3 becomes the adjacent, so 3 over 5. So, where we can apply these trig functions is angles of elevation and depression. So, angle of elevation is when you tip up, angle of depression is when you tip down. So, from a horizontal line, if you're going down from the horizontal, depression. If you're going up from the horizontal, elevation. So, if we look at this hiker dude here, he's hiked up a hill, but he's looking over this mountain. He's also looking down at the village. So, angle 1 here, if you're up here at the mountain looking down at the hiker, that would be an angle of depression. If you're the hiker and you're looking up at that mountain, though, angle of elevation. The hiker looking out at the cabin, angle of depression. But if you're at the cabin looking up the hiker, angle of elevation. So, looking up at something is elevation, looking down at something is depression. So, think that's from the horizontal. So, straight out, going up, elevation, down, depression. So, place where we could use this. To find the height of Delicate Arc in Arches National Park in Utah. I actually drove by this. This is pretty cool. Surveyor levels a theodolite with the bottom of the arc. Theodolite, it's the same thing as a transit. It's pretty much, it's this little deal here. It's got like a scope like on a gun and allows you to zero out. It has the angle measures. Zero out and just pivot up or down to get the angle of elevation is all it's really doing. So this person's here, zeroes it out, goes up, sees that it's 48 degrees to the top of the arc. So she's wanting to know, how tall is this thing? But remember, this thing is 5 feet off the ground, so that's where the 0 mark is. She's also 36 feet away. So we have an adjacent, we have an opposite, and we have an angle. Adjacent, opposite is tangent. So we would set up tangent 48 degrees equals opposite x over adjacent 36. And then from here it's solving like what we did in 8.3. So we would times by 36 to get rid of it off the bottom, which means we have to times this other side by 36 to keep it balanced. So that's what we're going to put in our calculator. (36 tan 48). And we get 39.98, so in other words, about 40 feet. Now, keep in mind, that was 5 feet off the ground in order to get level with the theodolite. So if we add 5 in, we're really at 45 feet. So that would be how tall it actually is. Another place is, if any of you have ever taken an airplane ride, they're using angle of their descent, the angle of depression. They can only descend so fast. So they have to know, okay, if we are this far out, we need to start our descent, start lowering it, because we can't drop too fast. So So to approach the runway, the pilot can begin a 3% descent. So they're dropping at 3 degrees at a time. From an altitude of 2714. So 2,714 feet. So the airport altitude is 1,007 because altitude always goes off of sea level. So obviously if we're on land, we should be above sea level. I want to say Nebraska is somewhere around this 1,000 to 1,500 feet above sea level. So this is kind of like where we're at. But to do this, then we're setting this up. So really, we're going to track this and make this a right angle. We're going to know this. We know our altitude here. I'm going to call this one Y for right now. Now, if this goes down 3, this here will also go or be 3 because these are alternate interior angles. Because we have horizontal, which are parallel lines. This is that transversal. Alternate interior are congruent, so this would also be 3 degrees. Now, to find Y, let's start there first. We need to know how many feet do we need to drop. We know we're at 2714. But we also know the airport's only at 1,007. So we don't need to go all 2,714 feet. We just need to get down to 1,007. So we're going to subtract that out. And when we do that, we get 1,707. So that's really how much we're dropping. So we still have opposite and adjacent. So we're going to use tangent again. So tangent, our degrees is 3 degrees. Opposite is 1,707. Our adjacent is X. So in this case, times by your X to get it off the bottom. That still doesn't isolate it. So we have to divide them by tangent 3. So that cancels and X is by itself. So how we're going to do this one is, when you put it in your calculator, 1,707 and then divide by then the tangent of 3 degrees. So when it's on the bottom, that's how you'll have to solve these. And you'll get 32,571. I will leave it at that. Just looking at my notes, I use sine on this. I'm trying to figure out why did I use sine. Because we don't need to know how long a descent. So yeah, we're doing it right. I have my notes wrong. So this is far out from the airport. We would have to start this descent. That doesn't mean that's how far we're going to fly, but we need to be this far out before we do that. Now, they want to know how many miles. So we're going to divide this by 5,280. Which is going to end up being 6.2 miles. So we get the same thing in the end, and that's really because this is only 3%. There's not a whole lot of difference between these two. But that is it. That's the end of this lesson. Questions, comments, concerns, send me a message on Google Classroom or email is the best. You can also pan me, but just know I may take a little longer to respond. But until next time, we'll talk to you later.